I recently unautomated my smart home in order to make it even smarter. Let me explain. So in my office, I have a smart home scene called desk mode. And this is meant to be used whenever I sit down at my desk, whether it's to work or play games or whatever. It basically turns off all the lights in the office and turns on this mood lighting to make it really cozy. Now, up until recently, I was using this Aqara FP2 presence sensor to trigger this automation. This sensor can detect exactly where I am in the room at all times. So I had the desk mode triggering whenever I sat at my desk. And this worked like magic. Anytime I sat at my desk, the lights would all dim down and it would be perfectly set up for me to work. Now, this actually ended up being a classic case of over-automation, because even though 90% of the time I did want all the lights to turn off when I sat at my desk, that 10% of the time I didn't want them to turn off when I was working on a project or whatever, ended up being way more of a pain in the ass than what it was worth to have the cool, seamless automation for the other 90% of the time. To fix this, I tried adding some contingencies to this automation, having it only triggering at a certain time of day. This is normally a great way to solve this problem, but it still ended up not working out for me. So I actually ditched that automation entirely, and I instead took one of these smart buttons, which are totally wireless and be used to trigger scenes in your smart home, and I put that under my desk. So now whenever I want to trigger that scene, all I need to do is lightly tap the button under my desk. It takes almost no effort, and I have full control of when I want that automation to happen. For anybody that wants a real smart home that's fully integrated into your life, over-automation is a thing, especially if you have other people in your household that might be bothered by those automations, so you need to be constantly thinking about ways to get around those over-automation problems. Conditional automations and these little push buttons are a great solution. If you guys have any questions, let me know in the comments. Let me know if you've ever over-automated anything yourself, and I'll catch you in the next video. USB-C is way cooler than you think it is, and I'm gonna use this incredible little board to explain to you exactly why. Buckle up, because you're gonna learn a lot about electronic stuff in a really short amount of time. So this is all about how USB-C delivers power. I could have this cable plugged into my laptop and it's charging it at 20 volts with a ton of power. Now I could take this exact same cable, plugged into the exact same power brick, and charge this phone at 9 volts without having to change anything. How is that possible without frying the phone? And that's because every single USB device that uses power has one of these little chips on it. And this chip's job is to literally send a signal to the USB-C power brick and tell it exactly what voltage to output. So you could have two different devices with two different chips on them, plug into the same power brick, and get totally different output voltages. This is very unlike USB-A, where it's just a direct line that outputs 5 volts all the time. Which brings me to these boards, which are a really great teaching tool to show you this in action, as well as just an amazing component to have to help power your projects. So the way that these work, there's a bunch of different solder pads here, and you'll see there's different voltage levels on them. Depending on which pad that you solder and bridge to the resistors beside, that's going to change what voltage that the chip is requesting from the USB-C charger. This is so cool. Let me show you in action. So I've got these wires soldered up to the output of the board and just connected to the multimeter so you guys can see the voltage. And you'll see here that I currently have the 12 volt pin bridged on this board. I'm just going to plug it into my USB-C power supply here, and we're going to see that we're getting 12 volts out of the board. Really dope. We're going to use the exact same power supply here. We're going to change nothing except for bridging this gap from 12 volts to 9 volts. We're just going to solder that over, change what the chip is requesting. Quickly do that here. So I didn't do the prettiest job, but you'll see now that we have the 9 volt gap bridged. What we effectively did there is just reprogram the chip. Now watch this. We plug into the power supply, nothing has changed, and we're now getting 9 volts output. This is such a cool way to illustrate how the USB-C chip works when requesting power. Now normally we'll just program the chip in the factory for whatever device that they're building, but this is such a great tool to have on hand, especially as a tinker if you want to use USB-C to power your device, but you need variable voltage or high voltage or low voltage or something that you're just able to bridge these gaps in a nice compact little power supply and power any device is super sick. If you guys have any questions at all, please let me know. I hope you guys find this at least somewhat as interesting as I do, because I absolutely love this stuff. Thank you for watching, and I'll catch you in the next video.